The power of pseudocode, how to plan your code before you write it. Writing code can feel like diving into a complex puzzle without a map. That's where pseudocode comes in. It's a powerful language agnostic tool that helps you plan your logic and algorithms before you write a single line of actual code. Think of it as a blueprint for your software, allowing you to focus on the problem solutions rather than the syntax of a specific language. This approach helps you think more clearly, avoid common errors, and make your coding process more efficient and less stressful. Why pseudocode matters? Pseudocode isn't just for beginners, it's a practice adopted by professional developers to tackle complex problems. Here are the key benefits. Clarity and simplicity. By removing the strict rules of programming languages, you can express your ideas in plain English. This makes it easier to understand and communicate your logic to others, regardless of their coding background. Error prevention. It's much easier to spot logical flaws in a few lines of pseudocode than in 100 lines of code. By planning your logic first, you can catch errors like infinity loops or incorrect conditions before they become time-consuming bugs. Language independence. Because it's not tied to a specific language, you can create a single pseudocode plan that you can then implement in Python, Java, JavaScript, or any other language. This is especially useful for developers who work in multiple languages. AI as tool for pseudocode. Modern AI models are incredibly effective at converting well-structured pseudocode into functional code in various languages. Instead of asking an AI to write a user authentication function, you can provide it with your pseudocode. This gives you more control over the logic while still leveraging the AI's ability to handle syntax and boilerplate code, effectively making the AI a powerful productivity tool rather than a replacement for your own thinking. A practical example: user authentication process. Let's illustrate the power of pseudocode in a common task, user authentication. We'll outline a function that checks if a user's login credentials are valid. Step 1. Brainstorm the logic. First, think about the steps a program needs to take. For a login function, the high-level steps are: first, receive the username and password. Second, find the user in the database based on the username. Third, if the user exists, compare the provided password with the stored password. Fourth, if the passwords match, the login is successful. Fifth, if any of these checks fail, the login fails. Step 2. Write the pseudocode. Now let's translate this into clear, readable pseudocode. Use simple commands and indentation to represent the flow. Step 3. Implement in a real language PHP example. With our clear plan in place, writing the actual code becomes a straightforward translation. Here is how this might look in PHP, assuming we are using a framework like Laravel or a similar ORM. Notice how the structure of the PHP code directly follows the pseudocode. The comments in the code even mirrors the steps outlined in the planning phase. This makes the code easier to read, maintain, and debug. Your AI programming partner. By providing well-structured pseudocode, you can leverage AI to accelerate your workflow. For instance, you could give an AI the pseudocode from the previous example and simply ask it to convert this pseudocode into a Python function. The AI will handle the syntax and common idioms of Python, leaving you to focus only on the logic. This is a powerful shift from letting an AI generate a black box of code to using it as a smart, syntax-aware assistant. In conclusion, before you start typing code, take a few moments to plan with pseudocode. It's a simple but invaluable practice that will not only improve the quality of your work, but also change the way you think about problem solving in programming.